the audience to engage in the open forum after the seminar. Our speaker this afternoon is a professor of plant ecology at the Institute of Biological Sciences, University of the Philippines, Los Baños. Since 2009, she has been holding the rank of UP Scientist under the University of the Philippines Scientific Productivity System, which encourages and rewards scientific productivity. She is currently implementing several projects, including updating Magcale Biodiversity Information System, or MAKIBIS, with current web technologies, a prototype for centralized biodiversity information management system in the Philippines. She has published numerous papers in scientific journals and books covering a wide range of topics, including sustainability and food security in the Philippine uplands, vulnerability assessment to flooding and landslides and disaster risk reduction, bioenergy, green growth, and sustainable low carbon society, climate change and vulnerability assessment, water and nutrient dynamics in indigenous Muyong Paya systems, early warning system for fish kill into our lake, biodiversity information system, and managing environmental risks to food and health safety. She has received numerous awards in recognition of her exemplary achievements, including the National Academy of Science and Technology Outstanding Scientist in Botany in 1997, UPLB Outstanding Researcher in 2007, Philippine Soil Science Society Achievement Award in 2008, NAST Environmental Science Award in 2015, and the University of New England Distinguished Alumni Award also in 2015. She earned her doctoral degree in botany in the University of New England, Armidale, New South Wales, Australia in 1995. Master of Science degree in Soil Science and Bachelor of Science in Agriculture from the University of the Philippines, Los Baños in 1982 and 1979 respectively. A recipient of SEARCA Travel Grants Program in 2019, which enabled her to present her paper titled Bioenergy in Asia, Trends, Social Perceptions, Feedstock Preferences, and the Underlying Sustainability Trade-offs at the second annual Congress on Plant Science and Biosecurity held in London, United Kingdom. Please welcome a very good friend of mine, Dr. Magcale-Macandog.
Thank you very much, Kim, for that introduction. Okay, and good afternoon to everyone. I would like to thank you. So I required my students and asked my colleagues in the lab, and I also welcome other students for coming in, and also my students in my Bio 199 seminar. Thank you all very much. At least we have a good number here so that I can share with you what we have done for this Asia Pacific Network funded project on bioenergy. So I would like to mention my research team. First is Dr. Lilibet Acosta, who is from, at that time when we conducted this project, was connected with Potsdam Institute in Germany. Now currently she is with the Green Global Initiative, GGI, in South Korea. Yes. And then Dr. Kavi Kumar is a professor of economics in India, in Madras School of Economics. Dr. Su Peng Kui is also an economist and a modeler from Beijing Institute of Technology in China. But I think now he is based in Ireland. Okay, and then the local research team are Elena Eugenio, Paula Macandog, Dr. Arnold Salvacion, and Jemima May Aquino. So this is the title of my paper, which I presented in London last year, and I was very lucky to be awarded by the SEARCA Travel Grant, and in exchange for that, I have to present this paper here locally. Okay, so bioenergy. Okay, so just for introductory, just to level up. Okay, I just want to define bioenergy. So this is the energy from biomass. And it could either be raw biomass or processed biomass. So if you've been to our countryside, so you know it's very common, in the provinces that they just use pieces of wood or branches, so that's basically raw biomass that is being used for cooking and heating. Okay? And the other one is processed biomass, wherein we process certain species or biomass for bioethanol or biodiesel. So here in the Philippines, we use sugarcane for bioethanol production, and we use our coconut oil for biodiesel. So that's processed biomass. And as I have mentioned, we use sugarcane and coconut oil. These are basically feedstock. This is the raw material that is being used for processing biofuel. Okay? And we have first generation and second generation feedstock. The first generation feedstock, basically these are the crops that are being used for food, like our sugarcane, for coconut oil for cooking. So, and then non-reduced biomass like jandrofa is also considered as a first generation. Second generation feedstock would be biomass waste, crop residues, and trees and shrubs. They are second generation. Okay, so I mentioned all of this because our study will revolve around these preferences for feedstock among the three study countries in Asia. Okay, so policies promoting bioenergy has different focal objectives for different countries, but these four are the most common: for climate change mitigation, rural development, energy security, and for trade and economic growth. Okay, so this one I just want to show you the global production. So for bioethanol since 2001, it has increased from 20 to 50 in 2014, 94 billion liters of production globally. And for biodiesel, it started with it's smaller, lesser as compared to bioethanol. 0.8 billion liters in 2001, it rose to 4 and then to 30 in the 2013. And the graph there on the right side shows you the different producers, and of course US would be the highest producer for biodiesel. And then we have other countries like Brazil, Germany, France, Netherlands, and mostly European countries. Okay, so, and in most of these countries, it's the security for energy. Energy security is one of the most often cited policy objectives for bioenergy development. Okay, because we have experienced that we have these public concerns on energy security due to short-term volatility of prices. So you will always see that in the news that tomorrow the price of our oil will increase, and then the next day, and then let's say next week there's a decrease, but then the following day there is again an increase in the prices. So it's really very volatile. And we know that fossil fuels, they are not renewable. So it is definite stuff. And then if we continually mine this, if we continually extract this from the earth, there will come a time that there will be a shortage of this fossil fuel. So the long-term supply of fossil fuels is a questionable one. Actually, in Dubai, they know that, the United Arab Emirates, they know that maybe in the next 50 years they still have the supply of fossil fuel, but after that there will be no more supply. So what's their strategy now? If you notice it in Dubai, they are developing tourist destinations because that is their long-term goal. That's the long-term goal of their king. To make Dubai as a tourist destination in the future. Just like in Europe now, it's a tourist destination. It's a major economic source of income for the European countries. So for Dubai, that's also their projection in the future because of the long-term supply of fossil fuel is a very big question mark. It will decrease in the future. Okay. And we know that this long-term supply of fossil fuels will destabilize the economy because if we do not have fossil fuel, then the economy, the factories, the cars, we won't have fuel for them. So that's why alternative energy sources, it's a big thing in most of the countries, not only developed countries, but also economies in transition as well as developing economies. Okay, so global bioenergy trade is not limited only for biofuels, but also feedstock. Okay, so like in the Philippines, we export feedstock, okay, but not the biofuel. And you know, when you just export the unprocessed feedstock, you have only very little profit. Whereas if you export the processed one, you have a greater margin for profitability. Okay. Now, on the other side of the coin, bioenergy trade also has undesirable impacts, not only on specific communities due to social displacement. Why social displacement? Because, for example, these areas being used by, let's say, the local communities for, let's say, agroforestry system or for the cropping system. If it's going to be converted to, let's say, vast plantations of sugar oil, sugar palm, that's what is happening now in Mindanao, in Mozambique. So the local communities are being displaced. So not only in the Philippines, the same trend is also happening in China. So social displacement due to conversion of their farms into plantation for bioenergy is also a major issue. Okay. So, and not only social displacement, but also the entire population of these countries face threat of food security. Because instead of the crop being used for food, it's being used for bioenergy. Okay. So the controversies on the impacts of bioenergy production on food availability and affordability, because if there is lesser supply, then following the law of supply and demand, the prices will go up. Okay. So it will make food security as one of the most urgent contemporary public issues. Okay. And so the conversion of these agricultural crops and lands from food to bioenergy production has been claimed to contribute to short supply and thus high prices of major food commodities. And we have experienced that with our sugarcane. Okay, so there was a time that much of our sugarcane produce has been used for bioethanol production, and the price of our sugar shoot up. Okay, so we are the ones being affected, the consumers. Okay. So this apparent conflict between biofuel and food production, as well as increased food prices, have been described as food versus fuel debate. So it's a global debate. Okay. Rapid price increases in food commodities have considerable negative impacts on poverty reduction, and we know that poverty reduction is number 2 in the SDGs, Sustainable Development Goals. Okay. And also to reduce hunger. So these are interlinked because of the reduced supply of these crops for food consumption. Okay, and these undermine rural development in many developing countries, including the Philippines. Okay, only the first generation bioenergy foodstuff is often considered to cause a direct competition with food production, so that further development of advanced fuels from inedible, which means say second generation, and is being encouraged. But if we take a closer look, the use of such non-food crops, the use of such second generation crops also compete with food for land and water use. Thus, ultimately, these second generation crops also cause a decline in resources that should have been available for food production. So in either way, kahit first generation or second generation, it would still have negative impact on food production because it will require land resources, water, and other resources to grow these second generation crops. Okay, now this one, I just want to show you, okay, so we just focus on China, India, and Philippines. So for bioethanol production, production in China, corn, wheat, and cassava are being used. And for biodiesel, it's waste vegetable oil. Okay. Here in the Philippines, we do not use our waste vegetable oil. You know, that's one of my research that I'm thinking of, but I did not get funding for the EO. But I have already had initial discussion with them that, you know, we have lots of Jollibee, KFC, and yung wasted oil na yan. So, if we can convert that into biodiesel, that's a good resource for us. So, I think that our government should start thinking on using this waste material. Okay, in India, for bioethanol molasses, okay, Jadrofa faced a reservation project of Jadrofa more than 10 years ago, and our university officials even went to India, to learn from the Jadrofa growing and then processing of oil from Jadrofa, and then from Gambia. In the Philippines, sugarcane. For bioethanol and for biodiesel, we use coconut oil. So both of these are food crops. Okay, so first generation feedstock. Okay, so going back to my introduction, in addition to land and water competition between fuel and food production, the widespread system of bioenergy production is causing degradation of the ecosystem. Why? Because we have to apply oil, we have to cultivate, we have to apply fertilizer, we have to apply pesticides, we have to, and all of these may lead to a degradation of the ecosystem. Now, this photo here is, I got it from the internet, that this is the oil palm plantation in Agusa del Sur in Mindanao. So many of the areas in there are being converted into this monoculture planting of oil palm. Okay. Now, what else? Agriculture, okay, requires 70% of the total global water usage. Okay. And with increased biofuel production, it is envisioned, it is computed that it can go up to 90%. This is there is a very high requirement for fresh water, for this biofuel and food production. And then the use of pesticides, as I had mentioned earlier, fertilizer, okay, are being done to increase land productivity. And this will cause also more water pollution. You know that. So not only pollution, but it also affects biodiversity. Okay, so if your water bodies are polluted with these pesticides, it might affect even yung mga very young fish and shrimp and other aquatic biodiversity species. Okay. The dramatic increase in bioenergy production in recent years was achieved through conversion of forests into monoculture of soybean, sugarcane, corn, or oil palm oil plantations. Okay. Now, on the other side, because forests play an important role in storing carbon that is otherwise emitted into the atmosphere, again, this is one of the SDGs. Okay. The climate mitigation objective of bioenergy has been negated through large-scale deforestation, because instead of sequestering carbon, and then so it is offset by greater amount of carbon dioxide being emitted into the atmosphere because of deforestation. So the bioenergy production is very complicated if you look at it at different angles. Okay, energy security, food security, and ecosystem capacity are very much interlinked. Okay. There is thus an inherent trade-offs among them. So if you want to increase bioenergy, there might be a negative impact on food production and also on the ecosystem. Okay. These trade-offs are increasingly taken into account in nexus studies, where the word nexus simply means a connection or series of connections linking two or more things. So in here, in the diagram, they're showing you water, energy, and food nexus. Okay. Understanding the form of trade-offs can help avoid the selection of extreme management policies, which can result from considering smaller numbers of objectives and thus ignoring the real system complexity. Moreover, understanding the conflicts due to these trade-offs is particularly important for understanding welfare impacts, coping mechanisms, and environmental feedback effects at the local level. The study of energy, food, ecosystem nexus thus helps to inform about the need for not only a redirection in government policy, but also a change in societal behavior. Okay, so our study was to determine public perception. So it's some sort of a behavioral economics study on sustainable bioenergy and how they influence the preferences for alternative feedstock and the underlying sustainability frameworks. Okay, so what did we do? Okay, so most of my collaborators in the project from Germany, from India, from China, they're all economists and ecologists. So I invited Karim this morning. Karim, you come to my seminar this afternoon because he is an economist and he knows well the conjoint analysis. if they ask something about conjoint analysis, I will ask Camille to answer that one. But for the others, let me answer later. Okay, so the analysis is based on choice-based conjoint survey of respondents in 3 countries: Philippines, India, and China. Okay, and we surveyed different members of the society. We surveyed interviewed public employees, officials, private company employees, managers, academics, researchers, farmers, agricultural workers, and then we grouped all of these respondents into 2. Those related to agriculture and those non-agriculture professions. So we tried to compare the preferences between the agriculture and non-agriculture respondents. Okay, so what is conjoint choice analysis? Analysis is a practical technique for measuring preferences. So we ask them, what's your choice? What's your preference? Which one will you choose? Will you prefer? And assessing the trade-off among these decisions. Okay. The conjoint choice analysis is widely used in different scientific fields: psychology, economics, and environment, to transform subjective choice responses into estimated parameters. So that's when the economic analysis comes in there. In conjoint analysis, the attributes of an environmental good are used to understand the general trade-offs which an individual is willing to make. Okay. So, and then just to take note that these preferences, we all know that, okay? These are our choices, our preferences. If you think of it, they are influenced by our subjective perceptions and our economic, social, and cultural conditions. Okay? So, in this analysis, in this choice-based conjoint analysis, a set of attributes and the respective levels define respondents' choices. Okay. Specifically, the combinations of attribute levels define the choice task. I will give example later, virtually, in conjoint surveys, and address the 4 elements in conjoint analysis. Okay. Now, our framework is this one. We named it STRUCT: Sustainability, Trade-offs, and Pathways. STRUCT. Okay. And that's the name of our project, STRUCT. Okay. It takes into account the conceptual interconnections and interdependencies between the determinants and their underlying indicators. Okay, for example, okay, we have here attributes: economic stability. Okay, what are the determinants, okay, of economic stability? Okay, so we have energy security, technology progress, market organization. For social equity, okay, we have food security, social welfare, social justice, ecological balance, production potential, ecosystem capacity, and land management. And then for the indicators, okay, these are the levels of these different determinants. Okay, so for example, okay, these are the attribute levels. Okay, so let's say for economic stability, so we have 3: energy security, technology progress, and market organization. Now for energy security, we have 3 attribute levels: domestic energy demand, domestic energy supply, and the foreign energy trade. For technology progress, we have 3 attribute levels: the R&D investment of the country, technology deployment, and energy efficiency. Market organization, what are the market incentives, market infrastructure, and the trade constraints. In the middle one, we have social equity. So we have 3, we have food security, social welfare, and social justice. For food security, the 3 attribute levels are food self-sufficiency, purchasing power of the people, and affordability of the food. And then the second determinant would be social welfare. So the 3 attribute levels are livelihood sources, job opportunities, household lifestyle. And the third determinant, social justice. The attribute levels: equal property rights, home displacement, land dispossession. For ecological balance, the determinants, first one, production potential. So the attribute levels are the potential level and the feedstock sources. Okay. So that would be first generation or second generation feedstock. And then for ecosystem capacity, the 3 attribute levels are effects of population pressure, the pressure on natural resources, effects on landscape and species diversity. And land management, the three levels, attribute levels are the effects on nature conservation, compatibility with organic farming, and availability of good farming practices. Again, okay. So basically, these are what we are thinking of. Let's say for energy security, domestic energy demand, more desirable will be the domestic energy demand is low. Less desirable is when there is high domestic energy demand. Okay, so the problem is to supply this one. For the domestic energy supply, a more desirable scenario would be we have plenty of energy, and there is, and the less desirable scenario is there is very little energy supply. Okay, it's not enough to supply the demands of the society. Foreign energy trade, a more desirable would be for economic stability. You have low import. Okay, and less desirable would be high export. Okay. For technology progress, of course, for the three attribute levels, it should be high. High R&D investment, plenty of government funding for that one, technology deployment, and for energy efficiency, it's high also. And the less desirable scenario would be low on this. For market organization, the market incentive, more desirable would be high market incentive, less desirable would be low market incentive. Market infrastructure, good infrastructure, and for trade constraints, there is very low constraint. Okay, and the less desirable one would be the opposite. So that's the scenario for economic stability. For ecological balance, potential level, more desirable would be very high potential level, and less desirable would be the low, or the very low or no potential. For feedstock sources, more desirable would be crop forest residues, possible increase perennial grasses. What are these? Second generation feedstock. Less desirable is when you use starch-rich crops, sugar-rich crops like our sugarcane, oil-rich crops like our coconut oil. Okay. Resource capacity, effects of population pressure. Okay, more desirable would be production potential is unaffected by the population pressure. Less desirable is it is affected. Pressure on natural resources, we put less pressure on natural resources. We will take lesser environmental degradation. If you put more pressure, it will be subject to more or greater environmental degradation. Effects on landscape and species diversity, of course, a more desirable scenario will improve the diversity. The less desirable is you destroy or decrease in diversity. Land management, effects on nature conservation, okay, more desirable is that it supports nature conservation. Less desirable is it is in conflict with nature conservation. Compatibility with organic farming, a more desirable scenario is it is compatible. Availability of good farming practices, they are available. This would be more desirable, and the opposite would be the less desirable. Okay. For social equity, food self-sufficiency, purchasing power, affordability, in a more desirable scenario, they should all increase. The opposite would be the less desirable. Social welfare, livelihood sources, job opportunities, they both increase. Household lifestyle, it's improved. Okay. That's more desirable. For social justice, equal property rights, it supports equal property rights. Home displacement and land dispossession are prevented. Okay. So what did we do for our survey design? So in Germany at Potsdam Research Institute, they have this software, SSR software. So we just input in there, it is the one who's going to devise all the different combinations of determinants and attribute levels for decision making. Okay, so it will construct the choice tasks. Okay, so those are the ones. The choice task will be a combination of different choices that they have for economic stability, for the environment, for bioenergy. Okay, and it will also be the one to prepare the conjoint questionnaire. It's a very good software. Okay. And then you just input in there again, we encode the survey data, and it will analyze the responses of the respondents. So it has computabilities and preference weights. Okay. And then we used several ways. because we would like to gather more information and to reach more respondents. So initially we use the web platform. With the web platform, we have it online, and then that's it for me. I just send email addresses to all my contacts and ask them to answer online. But in India, this did not work well, so they had so much difficulty. So what they did was to conduct actual survey. Okay. We did also some actual survey in Pampa, Quezon, and also in Lipa, Batangas. Okay. In China, our researchers went also to the agricultural community, okay, which is the study site. I will show you that one later. Okay. And then, so online survey enables to reach different groups of respondents in different parts of the country with minimum expenses. But the problem is, maybe you have that experience that when you send email messages and you are asking for them to answer for the survey, you get very, very low responses. Even if you follow it up, no, they are not interested. Whereas if you go there and really interview them one-on-one, they have no other choice but to answer the question. So it's a combination of that one. We even contacted heads of institutions, okay, and asked them to disseminate the survey questionnaire to their staff and so on. Okay, so it's a combination of that one, online, web, and then later on we have offline. So we just have our tablet, and then we have our researchers doing the actual interview. Okay. So this is an example of choice tax that the software, this so-called software, produce. Okay, so I'll just read that one. Okay, so it's really quite a bit confusing, and then you have to take some time with your respondents for them to really think about it. Okay, so that's it. In this part of the survey, we provide you different imaginary economic conditions to develop bioenergy production. Given these conditions, which type of biomass would you choose to produce bioenergy in order to support economic development in your countries? So take out, we have 3 countries, India, China, and Philippines. Okay. So we have 3 types of biomass: sugar-rich, oil-rich, and fast-growing trees. Okay, so these are the 3 choices. Now these are the attributes. Energy security for sugar-rich, low domestic energy demand. Technology progress, high R&D investment in your country. Market structure, we have high market incentives, so this is one package. The second choice, oil crops. With oil crops, energy security, high domestic energy demand in your country. But your country has low R&D investment, and you have low market incentives. And then the third choice, let's say for fast-growing trees, you have low domestic energy supply anyway, high technology deployment, and you have good market infrastructure. Given these 3 choices and these attribute levels, you ask our respondent which one do you choose. So they will just answer, oh, I like the sugar-rich crops, or I like the oil crops. So, now, another question. In this part of the survey, we provide you different imaginary social conditions that will result from bioenergy production. Given these conditions, which type of biomass would you choose to produce bioenergy in order to support social well-being in your country? So you have, again, the type of biomass is starch-rich, agriculture, forest residues, and the grasses. And these are the attributes. For food security, starch-rich, you will increase food self-sufficiency. Social welfare, increase livelihood sources. Social justice, it will hinder equal property rights. So positive, these are the big negative. Now for this package, for the agriculture, forest residues, food security, it will increase your purchasing power. You will have more money to buy food. Social welfare, you will have more job opportunities. Social justice, it will cause home displacement. Okay, so the respondent will think about it. And then for perennial grasses, it will increase affordability of food. It will improve household lifestyle. But it will cause land dispossession. Now, which of the 3 will you choose? This is something that is available. Make their preference choice. So that's why it's a choice tax survey. Okay. So these different combinations is the software that is making these different combinations. Okay. So we have these 3 case study areas in China, India, and Philippines. In the Philippines, we have it in Batangas because we have their sugarcane, And then in Quezon Infanta, Quezon coconut grove. Sichuan in China and Tamil Nadu in India. Okay, more description on that one. So in the Philippines, okay, Batangas and Quezon are the main producers of sugarcane and coconut in the Calabarzon region. Masubu, Batangas is the home of the plantation of several azucareras in Don Pedro, the Philippines' largest producer of sugar and other sugarcane products. In Infanta, Quezon, 3 biofuel processing plants are installed or developed in there with total capacity of 140 million liters per year when we conducted the survey. In India, so here, photos of jadrofa cultivation. Here's the main source for the validity. So India, okay, so we picked Tamil Nadu because farmers are cultivating jadrofa. Tamil Nadu, which is located in southern India, is one of the earliest states to have promoted biofuel promotion in India. Okay, it has the largest cultivator of jadrofa in India with more than 20,000 hectares cultivated with jadrofa. And then in China, our study area is Cook County in the province of Sichuan. Okay, it's an agricultural community. It's a least developing area in China. And then in this one, in the recent years, a number of biogas poles have been constructed in Beijing, which uses pieces of crop residues to produce electricity. Okay. Now the results of our study. Okay. So how many respondents were we able to ask to answer the question for the Philippines? We have about 250. 150 are from agriculture-related professions or farmers. Non-agriculture-related, we have 100, academic, researchers, NGOs. Okay. India, 90 and 70, China, 52 and 116. It is very difficult not to get respondents from India. Our collaborator, Dr. Kami, has so much difficulty. Okay. These are some of the demographic characteristics of the respondents. For Philippines and China, majority of our respondents are below 30 years old. They are quite young. A few would be, this one would be high-level academicians. In India, most of them are between 41 to 50, so they are a bit older. Okay, most of them are farmers. Okay. For education, okay, so Philippines, most of them would have higher level of education, okay, undergraduate and graduate degrees. The same thing also in China for the non-agriculture. But for the agriculture, they are mainly farmers in the rural areas, in grade school only. For India, they have also high level of education, similar to the Philippines. And then for gender, for Philippines, we have almost balance, between male and female for both agri and non-agri sectors. In China, it's about 2/3 will be male, 1/3 female. But in India, majority are males. More than 92% respondents for both agri and non-agri. Okay. Domicile, since in China, most of them are farmers, so many of them are in the urban, here in farm agriculture, 63%. For the Philippines, we have a majority in farm and agriculture, but also in urban or city setting. The same thing with India. Place of work, so we try to have a good balance, from public agency, private NGOs, field, farm, academic research for the 3 countries. Okay, now this is very important content, knowledge and sources of information in bioenergy, Familiarity with the term bioenergy. Are you familiar with this one? Okay, so in the Philippines, for both respondents, for both groups, very high familiarity with bioenergy. In India, they are even more familiar, 100% probably because of these jadrofa. And China, for the non-agri, 63%, but for the agriculture, for the farmers, they are not very much familiar with bioenergy. They just concentrated in their farming. Okay, is your work related to bioenergy? Okay, so in the Philippines, for the agri sector, only 28%. But in India, they are sure, yes, more than 90%. In China, they are also not sure. So they are not aware, or maybe they just do not care if it's related to bioenergy. Okay. Bioenergy affects food security. In the Philippines, our group from the agri sector, 62% of it, yes, it affects food security, bioenergy. For non-agri, only 40%. Okay. In India, 50%. In China, for the agricultural sector, they are not aware that bioenergy has an impact on food security. For non-agri, about 50%. Bioenergy is good for your country. All respondents from the three countries, yes, said yes, so they are aware that in the future we will have problem with fossil fuels and bioenergy will be good for the country. Sources of information in the Philippines and also in India, mostly academic science will be high, and also media. In China, it's family for the farmers in the community. Okay? And for the non-agri, the academic science will be a good source of information about bioenergy. Okay, with regards to perceptions on the contribution of these different energy sources and types of biomass, feedstock to economic growth, okay, by country, so Philippines. So we have here the agricultural related respondents and the non-agricultural. First generation, it means to say our food crops, the English, okay. Now for the oil-rich crops, so we have, so take that for the colors. Blue is low, low perception, medium, very high, they regard it as high contribution, very high contribution for the purple, and the other group will do not know. So take note, in the Philippines, for the non-agricultural sector, we have here very high for the oil-rich crops, and for the agricultural sector, we have here high and very high. So our respondents that are agriculture related, they have very, very high perception. They would say that the oil-rich crops, particularly our coconut oil, okay, has a big contribution in our bioenergy because it's a main source for our biodiesel. Okay. Second generation, okay, so we have here very high for fast-growing trees. So non-agriculture, they would prefer to the fast-growing trees as well as bioenergy. And then for the others, high for farm or forest residues, fast-growing trees, and perennials. Now, in India, okay, so for them also, they have very high, okay, perception about the oil-rich crops. That is because of jet profile. In their country, the agricultural related respondents are very much aware of the importance of jet profile, oil-rich crop. Okay. For the non-agricultural, we do not have much, okay, preference for these different energy sources. They do not feel, maybe, they're not very much aware of the importance. And for the second generation, okay, so they also have, except for the fast-growing trees, in agricultural, this is hard, okay? But then in other areas, they have a very good perception. In China, okay, so it's a bit different, no, for the responders from China. And we have also presented that in the paper. Probably it's because we had so much difficulty getting a wider, a broader range of respondents because it's just limited to a small farming community who are not very much aware of the importance of bioenergy in its relation to food production. That's why we have this scenario. So they have low perception of that one. And except for the second generation for the fast-growing trees, so it has high preference for the non-agricultural sector. Okay, now with regards to the attributes of bioenergy on economic stability, so we have here Philippines. In the Philippines, so okay, the green one is type of biomass, energy security for orange. The gray one is technology progress, and the blue one is market structure. So you will notice here that in the Philippines, we have greater area for market structure. So it means to say, in the Philippines, our respondents think that having a good market structure will attain economic stability for bioenergy production. Okay. Then the next one will be the type of biomass that we are going to use. Okay. In India, okay, so the type of biomass, okay, they have high preference for this one. And for the non-agricultural respondents, they have also high preference for energy security. Okay. In China, okay, so they have energy security followed by the type of biomass as the major attributes to attain bioenergy sustainability in terms of economic stability. In terms of social equity, okay, in the Philippines, so we have here the gray one, social welfare. So it is actually higher for the non-agricultural related respondents. So social welfare followed by food security. These are the major attributes. Okay. For the respondents from India, the type of biomass and food security are the major determinants. And then for China, take note, it's more of social justice and social welfare. That is because they are mainly concerned with their social displacement, with the conversion of their agricultural farms for food production to biofuel production. Ecological balance. Okay. In the Philippines, our respondents would have high preference for land management and ecosystem capacity. Okay. Actually, production potential is also high. This is almost balanced for the three. Okay. In India, again, we have high preference for type of biomass. In China, land management and ecosystem capacity are major attributes that they have high preference in terms of ecological balance. Okay. Now this is a radar diagram to integrate those different preferences, okay, from the three countries. We can easily compare. So basically, when you look at this radar diagram, you just take a look at which leg is longer. So like for example, for the green one, that is China. We have the three points here, three corners: ecosystem capacity, energy security, and food security. So these are for the agriculture-related respondents. So from China, okay, they put a much higher weight for energy security. So it's a major concern for the Chinese respondents, energy security. Okay. For India, it's more for food security. Okay. And for the Philippines, the blue one, it's both food security and also ecosystem capacity. Now this is the respondent, the scenario for the agricultural related respondents. How about the other group that are not related to agriculture? Okay. So the orange one again is for India. Again, even from this group, food security is a major concern. Okay. The green one for China is energy security. And for the Philippines, it's again food security for the non-agricultural. So you see, we can take a look here, we can compare the different preferences of the different respondents from the different countries. No? Others would prefer more for food security. For India, it's more of energy security. And for the Philippines, since we are also very much concerned not only for food, but also for ecosystems stability, because we know that our country, we have so much environmental degradation, so erosion, flooding, and so on. So ecosystem capacity is also a major concern for the respondents from the Philippines. Okay, so in conclusion, the results of the conjoint analysis indicated that the preferred bioenergy feedstock and its role in sustainable development reflects the social and economic concerns in the respective Asian countries. That is, energy security in China, they really require high energy because of their so much fast development. Food security in India, okay, because junk food is really scarce in India, and ecosystem degradation in the Philippines. Overall, there is also significant awareness on the effect of bioenergy on ecological balance, not only in the Philippines, but also both in India and China, as revealed by the preferences on the determinants such as ecosystem capacity and land management. Okay. The high preference for energy security, as in the case of China, may thus overshadow other sustainability issues such as ecosystem degradation, kasi mas prefer nila yung energy. Okay. Thus, policy should carefully weigh the impacts of bioenergy development on sustainability issues that are closely interlinked, the energy food ecosystem nexus. Because the society may favor one or two sustainability issues at the cost of another issue. That is the trade-offs. Okay. And then I just got this one, the water energy food nexus. So we have the energy, food, and water. So for sustainable people, landscape, and ecosystems, there should be a balance. So the policy should really take a look into this one. And for example, here, the entry point here for energy security, governance, and investment. Okay. So for energy, so we have here demand, supply, and assets. Okay. Now our food here, okay. So food production, processing, and transport need energy. So that goes to the food production. Okay. So fossil fuel extraction, energy drugs, and carbon sequestration impact food supply. Okay, so the entry point here is food security, but with the policy, government policy, and investments. Okay, so that it can meet the demand. You know, the supply can meet the demand, and you still have access to food production. So water infrastructure and use impacts on fish stocks, food supply, and land use. And then we have here water. Okay, water. We have demand, supply, and assets. Okay, food production needs clean water, and impacts on clean water quality and availability. Okay, so because food, fertilizer, pesticides, it can pollute the water resources. Okay, and then so the entry point here for water security would be management and investment. Okay. So we have here, so water, we have demand, we supply assets, and then we go to this one, energy production, including sequestration, needs water. And impacts on water quality and availability. So that's why for sustainable development, we really have to consider this water, energy, food nexus. Okay? I think that's it. And if you're interested, we have published already this paper, so you can take this from agriculture in 2016. The role of bioenergy in enhancing energy, food, and ecosystem sustainability based on societal perceptions and preferences in Asia. So thank you very much.
Okay, thank you very much, Dr. Demi, for sharing with us the results of the conjoint survey. Survey of your study. So the floor is now open for your questions, comments. Please use the microphones along the aisle and kindly state your name and the office you're connected with for documentation purposes. So who's going to throw in the first question?
By the way, our funding agency is the APN, Asia Pacific Network for Global Change Research for this project. Okay.
Dr. Karim.